What's up, you rock stars? This is section 3.3, Functions, day 3 of 3, Domain and Range. And I just want to say outright that the capital of Kentucky is Frankfort, and that's all you really got to know. I've been there once. I had actually had Kentucky Fried Chicken in Frankfort, Kentucky. Beat that. Here we go. Domain is the collection of all input values. Now, the thing that we haven't said yet about the domain is that you can't include every number that you want in the domain for every function. You've got to exclude values that don't have an output. So it's the collection of all the input values that also have an output. If you want to put a number here in the domain, it has to have a corresponding number here. And there's actually lots of functions that have all real numbers as their domain. For example, here, you can see f of x is equal to 3x squared. If I plug in 0, I get out an answer of 0. If I plug in 1, I get out an answer of 3. If I plug in negative 8, I get an answer of 192. And it doesn't matter really what number you use for a value of x, you will always get a value out for here, the output of a value for the function. So this function has all real numbers in its domain because all real numbers can be input that produce an output. There's plenty more that have similar properties like this as domain as their all real numbers as their domain. There are plenty more functions that have all real numbers as their domain, and that's kind of the starting point. You can assume that they have all real numbers as their domain, except for if they produce any problems. But here, there's no problems. 0 is the input and 4 is the output. 1 is the input, 3 is the output. Negative 8, again, remember when negative 8 squared is positive 64, 4 minus 64 is negative 60. So yeah, every input has an output. And 0, 1, and negative 8 are just numbers that I chose. All real numbers here will produce outputs. Absolute value of x always produces an output. The cube root of x always produces an output, and that's not always going to be an easily calculatable number like we have here. If you're taking the cube root of 3 or 5 or something like that, then you're going to get a crazy long decimal, but at least you get a number, and that's fine. 0, what is the cube root of 0? What times itself 3 times is 0? 0. What times itself 3 times is 1? 1. What times itself 3 times is negative 8? Negative 2. All of these input have output. Every real number has as an input has a calculatable output. So therefore, all real numbers are in the domain. Where this gets a little tricky is when you have functions that don't produce output. Here are some examples of functions that have most real numbers in their domain, or many real numbers in their domain. They need to have an x value excluded because that x value does not produce an output in their range. Let me show you what I mean. Here, rational function, we've got x in the numerator, and we've got x squared plus 2x minus 3 in the denominator. Remember, the word rational means ratio or fraction. And if you wanted to, you could factor the denominator. You get x plus 3 and x minus 1. So when you plug in 2 as an input, you get 2/5 as an output. You just take 2 and put it in for x. 2 squared plus 2 times 2 minus 3, you get 2/5. Fine. Not a big deal. Try see what happens when you plug in 1. This should be a 1 on the top. 1. This should be a 1. This should be a 1. 1 over 1 squared plus 2 times 1 minus 3. You get 1 over 0. And that's a big, hairy deal. 1 divided by 0 produces no real solution. So the domain is going to be, and here's how we write it. The domain is going to be all x values, and this line means such that. The collection of all x values such that x is going to be not equal to 1. We want to make sure that x doesn't equal to 1. You can have any number in the world you want except for 1, because if you have 1, then you produce a 0 in the denominator here. What happens if you have negative 3? Oh, you can see right here, 1 minus 1 is 0. But if you did the same thing over here, if you plugged in negative 3 plus 3, you'd also get a 0 in the denominator, because 0 times anything is still going to be 0. So actually, we need to exclude 2 numbers. x cannot equal 1, x cannot equal negative 3. You can have any number in the world that you want, any real number, fine. Just make sure it doesn't equal 1 and doesn't equal negative 3. Because if you do, you'll get a 0 in the denominator. If we redefine f of x to be the square root of x minus 3, then we can, yes, sure, we can plug in 12. That's fine. 12 minus 3 is going to be 9 square root of minus 3. Not a big deal. Input 12, output 3. Input negative 12, what happens? We get a square root in the inside, negative in the square root. And I know you know that about all imaginary numbers, and you could say that this is just I root 15. However, the closer we get to calculus, the closer we're going to just ignore imaginary numbers. Because here, we're going to say that there's no real solution. There are imaginary solutions, there are complex solutions, but in terms of real numbers, there's no real solution. That's actually going to occur anytime this radicand in here, the stuff inside the radical, is going to be negative. So we would just want to make sure that x minus 3 stays positive, or at least not negative. It can be equal to 0, fine. It can be more than 0, fine. But if it's less than 0, you got a problem. So solving this, you get x, adding 3 to both sides, you get x is greater than or equal to 3. So that's going to be our condition. We can say, we can choose any x you want such that x is going to be greater than or equal to 3. That's the domain here. Domain x such that x is greater than or equal to 3. Here, this is a radical function and a rational function. It's pretty messy. If you plug in negative 100, for example, no problems in the denominator, you can calculate that. But if you get the square root of negative 503, then all of a sudden you got to say, wait a minute, there are no real solutions. When is this going to occur? It's going to occur whenever what's inside the radical 5x minus 3 is negative. You want to make sure that it stays positive or at least not negative. So not negative is greater than or equal to 0. 5x minus 3 is the same thing as 5x greater than or equal to 3, and so x has got to be greater than or equal to 3/5. You can have any x that you want in the domain. Just make sure that x is greater than or equal to 3/5. If you do that, then you'll make sure that what's inside the radical stays positive, or at least not negative. There is a possibility in this kind of a function that you might have a 0 in the denominator, so let's check for that too. When is it exactly that x squared plus 1 is going to equal to 0? Well, if you subtract 1 and then you take the square root of both sides, all of a sudden you see there are actually no real solutions. So we don't have to worry about zeros in the denominator. Now you know and I know that there are imaginary numbers running around out there, but in this section we're not going to worry about it. There are no values of x that are going to produce a 0 in this denominator, so we don't have to worry about that. Here's the big idea. That's what I really want to say, is this. To find the domain, because this is going to show up a lot in the assignment, it's going to say, give you one of these functions and say, find the domain. You need to ask yourself, are there any x values that produce any one of these two things? A 0 in the denominator or a negative in a square root. If those things are occurring, then you have to remove those x values from the domain that produced that. Here we removed 1. We removed negative 3. Here we removed all the x's that produce negative in the square root. This is a process of exclusion. Exclude the x values that produce the problems, the 0 in the denominator, a negative in the square root. The answer is going to be all real numbers except 1, all real numbers except negative 3, or all real numbers just making sure that they are greater than or equal to 3/5. Begin 3C3, assignment 3C3, copy the problem list and do the first problem, and I will see you in class.